All right, we need some new definitions for trig ratios because we no longer have a right angle triangle necessarily, or we no longer have an angle that's restricted to 0 to 90 degrees, right? That theta angle there has to be less than 90. What do we do for the sine, cos, or tan of 174 degrees or 250 degrees? So let's go back to our original definitions. So in a right angle triangle, sine theta is equal to opposite over, and cos theta is, and tan theta is. However, what is the sine, cos, and tan of an angle larger than 90 degrees? What's the sine, cos, or tan of a negative angle? We need a new definition for sine, cosine, and tangent ratios to address all types of angles. The new definition for the trig ratios of theta, an angle in standard position involves a point on its terminal arm, P, which has coordinates x and y, and it involves r, the distance from the point to the origin. If a vertical line is drawn from point P to the x-axis, then a right triangle is formed. If the distance from the origin, 0, 0, is denoted by r, and note distances are always positive, right? Then by the Pythagorean theorem, x squared plus y squared is equal to r squared. In this triangle, sine theta is opposite over hypotenuse, which is y over r. Cos theta is adjacent over hypotenuse, which is x over r, and tan theta is opposite over adjacent, or y over x. These ratios, sine theta is y over r, cos theta is x over r, tan theta is y over x, are the new definitions of trig ratios of angles in standard position. Okay? So when an angle is drawn in standard position, which we did a lot of yesterday, well, you did a lot of yesterday, I did it with a different group, which we did a lot of yesterday, we take a point on the terminal arm, we call it xy, we use x squared plus y squared equals r squared to determine r, which is always positive since it's a distance from the origin. X and y have whatever sign they have based on where they are on the coordinate plane, right? Okay. The point -4, 3 defines theta, an angle in standard position. Determine the exact value of sine theta, cos theta, and tan theta. All right, first thing I do for any of these is what? Draw a diagram, right? Draw a picture. You got to see what you're dealing with. So I want the point -4, 3. -4, 3. We'll call that point -4, 3. This is the angle theta in standard position. This is -4. This is 3. The point is -4, 3. Okay. So this is what we're dealing with, right? We have a point on the terminal arm, -4, 3. The angle theta in standard position measured from the positive x-axis with a counterclockwise rotation, right, as shown. And we want to know what sine theta, cos theta, and tan theta. So what do we need that we don't have? Yeah, we need the hypotenuse, right? Okay, what is it? 5. Are you good if I just say it's 5? Let's work it out just in case, right? So r squared is x squared plus y squared. R is the square root of. Okay, and I'm not writing plus or minus, right? Because r is just the positive or principal square root. All right, what was x? -4. Okay, there. R is 5. In future, I expect you to look at a 3, 4 triangle and go, the hypotenuse is 5, just write it down, we'll take it as a given, okay? I won't expect to see any work, even if it says determine. It's 3, 4, yes, we all are smart enough to know that the basic Pythagorean triangle, the first one we ever learned, was a 3, 4, 5, right? Okay, so you've got R. So now we go with sine theta is equal to y over r. And I would suggest you write that down every time you do it for about the first two or 3,000 times so that it sinks into your head, right? Because you have to know sine theta is y over r. I mean, you can always go back to first principles, draw yourself a triangle, put in theta, and say, oh yeah, the y value is opposite. The x value is adjacent. Okay, what's sine theta? 3 over 5. Cos theta is x over r, which is negative 4 over 5, which we might write as negative 4/5. And tan theta is what over what? Y over x, which is 3 over negative 4, which is negative 3/4. All right, any questions? Okay, so these were nice numbers, right? 3, 4, yeah, it's 5, right? Now you get. Sometimes they won't be so nice. I think that's it for this. The point, negative 6, 4, defines theta, an angle of standard position. Determine the exact value of sine theta, cos theta, and tan theta. Express your answers in simplified radical where necessary. So these numbers may not be so nice. In other words, the r value is probably a radical. What's the first thing we do? Draw it. Find the point negative 6, negative 4. Negative 6, negative 4. That point is a point on the terminal arm of an angle theta in standard position. There's theta, the angle in standard position. We draw a right triangle, dropping a perpendicular line from the x-axis. What goes on here? Negative 6. What goes on here? Negative 4. What's r? Okay, I'm going to do this just a little bit less detailed, right? It's still, so r is equal to the square root of negative 6 squared plus negative 4 squared, which is root what? 52, which is 2 root 13, okay? So I'm skipping a little there because I showed you the full detailed thing, and you know, I think we can all. So the thing is, look, if you're doing this in your calculator, under no circumstances should you ever put the negative in when you are squaring a negative under the radical sign, right? Like for the quadratic formula, don't put negative 8 squared. Just, I mean, write it. You got to write the negative 8 squared, but don't in your calculator put negative 8 because you'll forget the brackets. You'll get a negative 64. Your brain will turn off at that moment, and you won't recognize that, wait, that shouldn't be a negative because I'm squaring a negative, okay? And you'll just take, well, that's what my calculator said, so I'm just going to put that down. And you'll blissfully get the wrong answer. I mean, we don't want that. So, you know, if you're squaring a negative under there and you're using your calculator, for this, just go 6 squared plus 4 squared. And don't do the square root of, because that's no good. Because you're not going to get 5, you're not going to get a nice number, right? We have root 52, and then we have to, you know, change that to mixed, from an entire radical to a mixed radical. All right, so anyways, now we know everything, right? Let's enumerate what we know. All right, so there's the summary. All right, what's sine theta? What's the formula for sine theta? Y over r, because we're going to write that down at least a couple thousand times till we've got it settled in our head. Okay, sine theta is y over r, which is negative 4 over 2 root 13. And how do I rationalize that? Yeah, multiply top and bottom by root 13. It's not really both sides. I mean, unless you're looking at it sideways, and then kind of both sides. Over what? Actually, you know, really at this point here, I probably should have just done this, right? So let's simplify a little more. So negative 2 root 13 over 13. So that's what sine theta is. Okay. What's theta? We don't know, right? I haven't got a clue. What's that angle? I don't know. I don't know what that angle. I know the sine of that angle, which is fine if I want to solve something where I need the sine of that angle, if I don't need to know the angle, right? Later we'll worry about those other details. What's cos theta? X over r. Good. See, you're starting to understand this. Which is? Over 2 root 13. All right, let's do a little bit of simplifying. So we get negative 3 over root 13. Negative 3 root 13 over 13. What's tan theta? Y over x. Okay, which is? There we go. Okay. Any questions, queries, comments, problems? Any wonderment? Keep going. Oh, here's one. If sine theta is negative 5 over 8 and theta is a third quadrant angle, determine the exact value of cos theta and tan theta. Okay, that's different. So what do we know? We know y and r, right? It's the young and the restless, but in this context, it's the y value and the r value. Okay, so what's y? How do you know that y isn't 5 and r is negative 8? Okay, because r is always? Yeah, r positive. No, r is positive. All right, it's a third quadrant angle. All right, so then I know that this point is something negative 5. So what's my x value, at least in terms of sine? Is it positive or is it negative? Negative. All right, so I'm looking for the negative value of x, right? So let's go over here and in great and gory detail we'll work this out. Okay, so x squared is what? R squared minus y squared, right? Algebraic manipulation. So x is plus or minus the root of r squared. See, because x and y, they could be positive, they can be negative. If it's r, I'm just doing the root of. Okay? But if it's x or y, I'm doing plus or minus. Now we know, because it's a third quadrant angle, we know we're looking for the negative value of x. All right? Because where else might the y be negative and the r, well, r is always positive. So where else could we be where the y value is negative? We could be in quadrant 4, right? So we could be over here. So being given this, there's not really enough information, right? We say, well, okay, that means I know the y value is negative, which means I'm below the axis, so I'm in the third or the fourth quadrant, right? But which one? Not really sure. Okay, so then they tell us. Okay, so for us, x is equal to the negative of r squared, so that's 8 squared, minus negative 5 squared. Oh, what's that? 64 minus 25? What's 64 minus 25? What is it? 39? 64 minus negative 5 squared. Being as we can never square anything and get a negative, it must be a minus. It actually is a minus, right? Also, root 89 is over 8. And being as the hypotenuse is 8 and must be the largest side, we can't get a larger side, right? So you need little alarm bells to go off, like, hey, I'm solving for one of the smaller sides and it's bigger than the hypotenuse. Maybe I made a mistake. Okay, so x is negative root 39. All right, what are we supposed to find? Cos and tan, right? All right, so let's go down here. Let's summarize everything so before it all disappears. Negative root 39. Y is negative 5. R is 8. If I go over here, if I want to, fill that in, negative root 39. There is my angle theta. No. In none of these are we being asked for what theta is, right? We don't care what the angle is. We're being asked what is the sine of the angle? What is the cos of the angle? What is the tan of the angle? And we're using our brand new shiny definitions, right? So what's cos theta? X over r. Some of you are learning and some of you aren't. We have not yet written this down 2,000 times, right? So we're still going to write the formula. Okay, so that's negative root 39 over 8. So what do? Multiply by root 39 over root 39? No, because it already is rational, right?
Rational.
There's no radical in the denominator. Okay, what else do we have to find? Tan theta, right? What's tan theta?
1 over x, y over
Y over x. And what are we going to do with this? Okay, so it's positive, right? Because y and x are both negative, so you got negative divided by negative, which is positive. It's got that root 39, which is irreducible, right? I mean, can't do anything with root 39. It's 3 and 13 are the only factors. And none of those are perfect squares. Okay, questions, concerns, comments, queries? In each of the 4 quadrants, state whether each trig ratio is positive or negative. Okay. So this is the sine of x, and this is the sine of y. And what do we know about r? It's always positive. So what's sine theta? Y over r. It's a positive over a positive, so it must be positive. What's cos theta? What's tan theta? Right, you fill in the rest. In pencil, have an eraser handy, in case you mess up. Okay, so figure it out, right? Just sine theta is y over r. What r is positive, right? Okay, so y is this and r is that, and that makes this that.
paths.
We'll get there, just relax.
Let's try to say backwards by calculator.
Yeah, no. I got a better one. I got one that starts in quadrant 1. But in the meantime, fill in the thing. You're not done yet. Are you? If I walk back there, will I see that you are done? Okay. All done? Okay. Wasn't hard, was it? Yes, no, maybe so. Yeah. Okay. So we're just basing it on the sign, which is kind of bad to say with sign being one of our ratios. So we could use polarity, right, as the plus or minus. So sometimes I'll use that, but not often. Mostly I'll say the sign of the sign is positive. So this brings up the cast rule, which is an easy way to remember which ratios are positive in each of the quadrants, right? So all of the ratios are positive here. Only the sine ratio is positive here, right? Since x is negative and 2 ratios involve x, tan and, here, only tan is positive because x and y are both negative, but a negative divided by a negative will be positive. And over here, it's the cosines is positive. So the easier way to remember this, I think, starting here, is to go all. So you start here, go all. I like that one.
All sides just combust.
Yes, if you heat them up high enough, they will.
What about biology?
Heat them up high enough, they will. I just have to reach the ignition point. There's a lot of fat on the bodies, man. I mean, once that gets going.
What about the signal pattern?
It's not restricted to science teachers, of course. Everybody. Okay, here's another one for you. You can go all students take comms. So if you don't want images of combusting science teachers in your head, depending on who your chem teacher is, you may or may not. then you could think all students take. Okay, whatever. Anyway, so that's the cast rule. I learned it as cast, right? The only problem with cast is it starts down in quadrant 4 and works that way. You know, cast makes a word and ast doesn't. Is that it?
Yeah.
Really? Oh, all right. Well, way you go. You got homework to do.